Yeah,
Thank you.
so we've had clouds and we've had perfect storms, and my thunder was nearly stolen just then with what Daniela was talking about. And so I wanted to start with my phone. So I can go into an app on my phone and I control my central heating, and I'm here. I can see what's going on. And much to the dismay of my in-laws, when I was in the pub with my brother-in-law, we turned down the heating on them as I was showing it, but they had no realization that that was happening. If I walk into my house, I have an Amazon Echo, I can go, Alexa, turn my heating up by 2 degrees. It's trivial, it happens, and we have all these technologies in our life, you know, the washing machines, the fridge freezers, everything is Wi-Fi, but when you walk into a lab, this is what you see. People just seem to forget about the technology they use in their day-to-day life. And you know, I think this shows it pretty well. You know, 50 years have gone by and the lab environment hasn't really changed that much. So, okay, it's colour now, but you know, it's the same sort of thing. But the types of science that we are looking to do is so much different from then. So, single-cell sequencing, omics, gene editing, imaging, all these things produce huge amounts of data, and our current infrastructure can't cope with it. I mean, it pales in comparison to the stuff that Alberto was talking about at CERN yesterday in terms of petabytes, but it is something that a lot of companies can't deal with. And so it's something that we need to address. So in October 2014, I actually moved to the US, to MedImmune in Gaithersburg. So I'm actually a MedImmune employee, and I was setting up a laboratory automation strategy for R&D. So I manage laboratory automation across all the R&D sites in MedImmune. And so, you know, those sort of strategies go along and they do the same sort of thing, next generation of liquid handlers, etc. But we really want to look at what we thought may be transformational going forward. So I'm lucky enough that I have a really good boss that is willing to invest in risk. So I asked for a piece of lab, which is actually quite a rare thing to get these days. And I ripped it apart with some colleagues, put a lot of mobile benching, etc. Nothing special there. But within 3 months, we launched that lab at the annual science fair in Gaithersburg. So we had 3D printing, cell imaging. There was a buffer prep system that you could order from your mobile phone at home. So if you want to order buffers so that they're ready. We had eye tracking so that for people who are creating methods for clinical trials for people to administer the drugs, they can actually watch what the patient is reading when they read the clinical trial instructions. So if there's something that they're missing, they can look at that and say, well, why didn't you look at that? And they can alter the protocol accordingly so that they do. So it was a 2-day event. It happens every year, and we had 300 people come through the lab space, scientists and non-scientists. And I don't know if you've seen at the airports these days, you have these happy or not systems. They're just a button you press, whether you're happy, like whether you're patted down enough for security, etc. So I got one of those because everyone hates doing surveys. No one likes to fill them in. So a quick, are you happy, yes or no? Of those 300 people, 93% were happy. People went away and sort of forgot about what the lab was about. So it was a real challenge for the next 12 months to really sort of put forward what it was about. And I think one of my lessons learned, I'll come at the end, is one of the biggest challenges is actually cultural change and the way people work. They've always worked in a certain way, and that needs to change. And if we want to attract the new talent that's coming out of universities and retain that talent, there's something we need to do about it, because they're living with new technologies that they just expect on a day-to-day basis. So as part of the success of that and off the back of it, I was asked to join a group across AstraZeneca to look at developing a global lab IT roadmap. And the reason is that you may or may not be aware that AstraZeneca are building a brand new state-of-the-art facility in Cambridge in the UK. So they're moving from the north to the south. You know, it's hundreds of millions of dollars worth of building space. But the plan is just to lift and shift. because times are hard, patents are falling off, and so they're trying to limit what they spend. So it's lift and shift, and the building is already full. It literally has a glass ceiling on it. It's designed by a Swiss architecture company, so it looks very good. And all of the walls are made of glass. So it presents some challenges of you can't store stuff, hang things off glass, etc. And so what we wanted to do was we wanted to go out there. We've created this vision where we wanted to create a space that would allow innovation and collaboration. And what it comes back to at the end of the day is making sure that we can deliver medicines to patients. And that's what pretty much everyone goes to work for. So first thing we did was we did some external benchmarking, and slightly funny story in that my next couple of slides are by Gartner, and I only found out yesterday at lunch while having lunch with Michael that they were actually his slides. So I asked him for permission yesterday. He said yes. So we engage with people like Accenture, Transcriptic, which is like a cloud-based automation company, and MedImmune is a sponsor of the MIT Media Lab, which is a blue sky thinking institution. They do a lot of wacky things, but there are some really interesting technologies that are coming out of that space. I'll talk about later. So these are Michael's ripped slides. So yesterday he presented the convergence of the physical with the digital, and you can't really see it well in the bottom, but all the CIOs that were interviewed pretty much have sort of mentioned anything anyone's been talking about over the last 2 days of where we should be looking at. So IoT, cloud-based, mobility, all these sort of things. And they pretty much tick all the boxes of the problems that we have at AstraZeneca and MedImmune. So, I think before we heard that there was 8.2 billion things connected to the internet. And there's all these startup companies, and you wonder, well, where are you going to start? And so for me, I've just started a new role back in October of this year when I moved back to the UK. I work within a tech incubation group within the IT organization, but I represent R&D. So for me, the focus should be, what are the questions that R&D are asking? And then going to IT and saying, well, what are the solutions that are out there in transformational technologies that can answer that question that actually gives value? It's not a case of, oh, here's a really cool technology, where can we put it? It needs to be driven by the business. So from my perspective, 75% of what we should do should be driven by the business, and 25% should just be out of curiosity. And that sort of stimulates innovation. And so, as I mentioned yesterday in one of my comments, enterprise IT is a funny organization because, a lot of people don't have the understanding of science. They understand IT, so Office, and all those sort of big enterprise applications. And even in the R&D space, they're used to the big applications. And so it's a real challenge trying to educate those people of maybe different ways of working. And maybe the first thing that they would normally do is they would go out and talk to Google, Amazon, and those sort of companies, rather than, because they've got collaborations with them, rather than maybe some smaller startups who may actually be the next big thing and could do something at a quarter of the cost. So AstraZeneca is a global organization, and in terms of the R&D sites, they're across Europe and the US. And there's small molecule, there's large molecule, there's a whole host of disciplines. And so what we wanted to do was look across the organization internally and sort of listen to the scientists. What were their problems? What do they think we could solve, etc. And actually, the funny thing is that even though small molecule, large molecule across different organizations, very culturally different, everything came back the same, pretty much 90%. And it was we want to concentrate on the science, and we want to stop doing the non-value added tasks, okay? So there's two levels of things there. So just a couple of examples. At the moment, the labs are sort of seen as overcapacity, and our current IT infrastructure can't really support the sort of things that we're doing today. And depending on where you are, at which site, you spend an same amount of time running between the lab and the desk. And so in Gaithersburg, the way the building was designed, you could spend 5-10 minutes walking from your desk to the lab. So people will then stay in the lab all day and they won't go back to the desk. And it sort of limits what they can do where they are. They'll miss seminars and they'll miss staff meetings because they are staying there whilst the incubations are going on. And again, so there's this constant moving between labs and desk, meeting rooms, etc. And what they really want to move to is to the right-hand side of the slide. So what you're seeing there is an organ on a chip. So we're quite interested about how we may change to doing in vivo work and using more human-like tissues to be able to check out for toxicity. So what you're seeing here is a technology that was driven out of the Wyss Institute in Harvard in Massachusetts. And there's a company called Emulate Bio that's spun out to deliver these chips. So this is a chip of the lung, basically. Their idea is that basically you could link all these chips together of different organs and you can see where your compound of interest is moving through. They want a space that adapts to science. So when everything's bolted to the floor, it becomes a very expensive infrastructure cost. And so in the new facilities, that's not an issue, but in some of the legacy sites, that is. And they want the access to data everywhere. In our personal lives, we store everything in the cloud. At work, we store everything on a server, or even worse, we actually store it on our computer because we think that's the place I can get my data to the most quickly. So, there are two levels here. So the first level is strengthening the foundation. It's to do the simple things really well. So how do we become more efficient? How do we simplify working? So at the moment, we're working with the likes of VWR to be able to do automatic restocking of consumables and those sort of things. And we have one of the worst ordering finance systems, I think, I've seen. And people spend so many times having to reconcile invoices and the things that scientists shouldn't really be doing. And people want to be able to collaborate wherever. Nowadays we do a lot of collaborations with academic institutions, and so being able to talk to those people readily is something we see as important. And then at the top, at the top we can see the sort of more transformational things. And so that's where I'm sort of going to concentrate on today. So we coined the frame seamless science. And so the idea is that you could move between the lab and your desk anywhere, and your experiment follows you. So that the data can flow between a lab and the office. People want to share their data more readily. We're very secretive about our data, and we don't like sharing it at a high level, but our scientists want to be able to share that data more readily than they currently do. And how do we design a space that's more efficient? So on the left-hand side, I see the lab as a very analog status at the moment. The things on the left are the very simple things that we need to do well now. And then what you're seeing, I'm going to go through a number of proof of concepts that we've actually completed. And you'll see these as more of the sort of transformational examples. So it's quite nice to hear yesterday Michael and Daniela today talking about knowing where my instrument is, being able to book it, etc. And so we worked with Accenture over a 30-day period. They have these teams that come in, understand your process to develop a wireframe. It doesn't cost you any money, thankfully. But the idea is that maybe you might want to go on and develop it. So people want to know where the instrument is, its location, history, and documentation. And so Daniel was alluding to the art of the possible. People want a live dashboard of what consumables are in the lab as well. Maybe we can have the seminars and the staff meetings projected to the labs. If you ever go into a lab and you see a whiteboard, it's scrawled upon all the time. And no one dares wipe the whiteboard clean because they don't know what was someone else's information. But the ability to maybe whiteboard and then send it by email to yourself rather than having to take a photo and it just getting messy is something that people want to do. We're still taking photos, and if people want to talk to someone, they have to leave the lab. So wouldn't it be great if I'm in the lab and I get my results, and then I can call my supervisor outside the lab, and we can discuss those results, and then at the end, I can maybe go away at that point after having a discussion, and I can change my experiment for tomorrow, rather than me walk to the desk and find out he's not there. And the same with maybe external collaborators. So you're going to see a video now. This is the app. So this is running on a Microsoft Surface Hub. Sorry, this is a wireframe. So here I am going through the instruments. I can choose the instrument that I want, and I can look at its calendar and set it. And then you'll see in a second that it'll show now that the instrument's available till 4 o'clock. I can click on it. I go to specs. I get a rating like Amazon. It tells me how reliable it is. I can see where it is in the building, and I can see user manuals and support and maintenance. So it's all there in one place in the lab. What we're moving to now is consumables. So, I want to order something to run out. Simple task. I press order. It shouldn't matter what the process is behind it. It literally shouldn't be. It just be, I want to order something. I have to pause it here because actually there's company-sensitive information behind this slide because it's to do with internal multimedia. But the idea is that you'd be able to view videos of what's going on and even live events. I mean, to me, I believe that the sort of seminar where someone stands up on a stage is dying. I invited someone from MIT Media Lab to give a talk on expansion microscopy, which I'll show a little bit later, and hardly anyone sat in the room. Everyone basically used the dial-in details, and they used the WebEx. So, this person's taking a lot of trouble to get on a plane early in the morning to come along for an hour to do Q&A. People just want to do it at their desk. They don't want to have to turn up to a meeting. So I think that's something that may change. Now, the next example is a smart bench. So, as I alluded to, MedImmune sponsors MIT Media Lab. And so they have an open house twice a year where you get lectures from all the different faculties, and then there's an open house and you can walk around all the laboratories. So there's a group called Fluid Interfaces, and there's a couple of guys there who have used a projector with a 2D and 3D depth cameras to basically project onto a table and make it touchscreen. Okay? For us, that sounds great. I can now project an experiment onto my bench, and it's not that the bench is an expensive, sort of chemically resistant to technology. It's from above. So a great thing for new starters. So if I want to get used to a protocol and someone's still shown me once or twice, I can still use it. If we want to do tech transfer between sites, because we all know that people interpret SOPs differently. And the example that I'm going to show you is just being rolled out. So it's manual cherry picking. So most people do cherry picking of bacterial clones on a piece of automation, but when it's a low enough throughput, or maybe it's in use, people do it manually. So what you're seeing here is projection. This is actually on a HP Sprout, but you can start to see that it's telling people where to put their stuff. Okay? And the person's interacting with the screen. They're deliberately choosing the wrong barcode so that they know the software works. And you can see in the top left-hand corner, this is a fidicial, and it links the plate to the fidicial. So you'll see in a second, actually, that the person can move the plates away from where they started, and the projection moves with them. So maybe if someone's left-handed or right-handed, or they've got a different style of working, they can basically move it around. And so it's now projecting where they need to pick from and to, and they're currently using a foot pedal to move it on per transfer. We actually see this as being a great opportunity in the manufacturing and operations space where you've got really validated SOPs that you can lock down. There's also an analytics engine behind it, so it records the time taken for each step. So if you think in manufacturing and you've got a lot of different people, maybe variability, you can look at the analytics behind and actually see, does someone need training more than others, or is the timing more, unrealistic to what people think. So you can start to get a real depth of information. Augmented reality, so here we go. For me, you see people doing manual tissue culture. They're doing aseptic techniques in a cabinet. And so, what you see at the moment, so they're using their hands, and then they've actually got their SOP stuck to the grill. It's sucking it down. They put their hand down, they turn the bits of paper, etc. Well, wouldn't it be good if they could just carry on doing their experiments? So this is something we did with a company called
OK, Vital.
Vital Enterprises.
Begin protocol. OK, Vital.
So you can hear the voice commands actually moving the on, so we can load it up. We can put in and open PDFs.
OK, Vital. Next page. OK, Vital. Exit document. OK, Vital. Complete step. OK, Vital. Play video.
So you can imagine I can do my experiment and I can just carry on doing what I'm doing. So
OK, Vital.
We're using a company called ODG, so the Osterhaus Design Group, for the glass technology.
Remote assistance.
And I think, so actually here what we're showing is, again, that if you're doing something, you can actually connect to someone who's not in the lab. So we've called someone out of the lab, they've paused it, you get an image of this on the glasses, and the person that's at their desk can actually annotate, and that then goes back through the glasses. So this is used for an experiment, but we definitely see it as an opportunity where you have vendors who want to troubleshoot pieces of equipment, and rather than call someone out, they can actually dial into the glasses and see what they're doing. The good thing with the ODG glasses as well is that you can change the lens strength on them. But there are two things. One was a great point around batteries, so they last an hour. So we're showing the art of the possible, but it's not possible because of battery life. The other is around voice. So the guy that did this for us, it's based in Silicon Valley, but he has a posh English accent, okay? It works perfectly. Me with my northern accent, it totally ignored me. And so all the things that you're seeing here today, we actually presented to our senior executive sponsors of the new Cambridge site. So that's Pascal Sorio, CEO, Meni Pangalos, head of AZ Research, Bahija Jalal, R&D. So Pascal's French. There is no way that we were going to let him interact with this. So we had to show a video basically of the technology. But I think that's one of the areas we're really interested in with Amazon Echo and producing in a manufacturing space. We're testing it to do SOPs. But again, these things need to work seamlessly. If you have to say, Alexa, do this, and you have to say it 5 times, people will give up. We just aren't quite there yet. So something a little less sexy. So I had a VP in research come to me, and he's saying, okay, we're going to lift and shift everything, but the bench space is only allocated for FTEs. No temporary, no postdocs, no PhDs. So I've got nowhere to put them. Can we look at a way at which we can actually try and increase the use of space in the lab? And so all we've really done is, we've identified a small form computer, which you'll see now. So this Intel NUC is as powerful as the computer on the left. And 3 years ago, MedImmune implemented an ELN. And as part of that rollout, every scientist got a Surface Pro tablet. So they actually have some software on there that allows them to connect into the NUC computer. So you can see we don't need the computer, keyboard, the monitor, the mouse, etc. And one of the nice things is actually, so here it's been left there, it's connected to the instrument. But if that's my Surface Pro, I can take it into a meeting room, I can take it to my desk or somewhere else in the lab, and it doesn't matter. I can then look at my experiments in real time. So if something does go wrong, I can address it. I don't come back an hour later and go, oh my God, I'm going to have to start again. I'm able to sort of keep an eye on what's going on in the lab. So my sort of last example is around IoT and sensors. So I've got two examples. So the first is in MedImmune in the US. So they have 600 upright fridges and freezers that line the corridors that they store everything in. And what happens is people ask for more freezers and they get given more freezers. There's no data to say you need to tidy your freezers up. These 600 fridge freezers cost $4.2 million per year in operating costs. You can imagine the amount of heat that's generated, electricity that's used, the service contracts, etc. And so we did look at TetraScience, but we've actually gone a slightly different direction. There's a company called Elemental Machines that do something very similar. We feel at the moment that their cost model is slightly better than TetraScience, although TetraScience's stuff is really good. And so one of the other things is by monitoring the temperature of these fridges and freezers, so the data is stored in the cloud, but you can start to look at the compressor cycles that are on these instruments, and you can start to maybe predict and generate algorithms as to when they may break down. This places a bit of a challenge with vendors because you're basically going to say, I want you to fix my fridge before it's going to go down. They might have a bit of trouble with that because obviously they are not waiting till it breaks. So there's a cost to the vendor. And then the other piece is around asset utilization. So again, people ask for equipment and they never they say, oh, we're at capacity, but no one ever has the data to show like everything is capacity. We just sort of accept it for what it is. So the top here is the readout from the Elemental Machine. So on the left is a graph of the temperature, and you can see there's a number of spikes there. The background here, that at the bottom, these are the compressor cycles, and these you can see the events when the fridge or freezer was open. So we've been running it for 6 months. We've had 20 sensors, and every 2 months we swap them over. So we'll have data for 60 fridges and freezers. And so you can see over here, there is one that is definitely not being used, and we can challenge that. However, a scientist is going to say, I don't care. I've got my freezer and I need it. I'm not going to empty it. But when the scientists come to you and say, do you know what we'd really like? We'd really like to have some lab managers to sort of manage the lab, the stocking and all these sort of things, but we can't afford to do it. So I say to them, well, I tell you what, you reduce your footprint by 25% based on the data that we're generating, you get your $1 million and you get your thing. So, okay, it's a win-win. This is, okay. And this basically is Spotify visualization where we've been using a company called Plugwise from Holland, they're a Dutch company, and they produce power monitors to measure power. So we're measuring between idle and in use. This is just the Future Lab that I set up in Cambridge, so just a couple of photos. I won't go into this too much detail, but again, we've got collaborations with MIT and Microsoft. And as I said, I've joined a tech incubation group in the UK where we're looking at interaction, data science, and sensors. And so we basically set up a test space for people to come and start to get to know these. So lessons learned, don't expect everyone to go at the pace you do. I've found out the hard way. It took at least 12 months for people to sort of try and understand it. Failure is part of the job. People don't want to invest in things because they're worried of failure. If you read, there's a book called Creative Confidence by the Kelly brothers at IDEO, and failure is fundamental in success. You need to understand the question to know what technology to apply, and you need to balance the risk and go out and look at other industries. And so, the lab needs to reflect the science being done today and tomorrow. Scientists want to collaborate everywhere. They want to be connected to the lab anywhere. And what we really need is for R&D to provide some investment to be able to change that lab environment. So at that point, I'll stop. Okay.